In the last two videos, I talked about the pros and cons of Node.js and Golang. If you haven't seen those yet, go check them out. I also covered when we might want to use one over the other. In this video, I'm diving into gRPC versus REST and how they perform. I'm not focusing on explaining the code itself. This is all about benchmarking and seeing how each one performs under load when two backend services need to communicate fast and frequently. If you're interested in the actual implementation, I've dropped a link to the full GitHub repo in the description below. Feel free to check it out, fork it, or even run it yourself. Now, what am I doing here exactly? I've built two backend services, one in gRPC and one in REST. The gRPC is right here, the REST is right there. Each has a main Go file in their respective payment service folders. That's the core of each service. So this is my gRPC server, and that's the REST. Very simple. All I'm doing is receiving a user, logging it, and then returning its name. And this server is running on port 551. And there's a message here. Once I run the server, we're going to see this in the console. The REST API, exactly the same thing. It's running, but instead of this port is running on 8080. Process user, same functionality, grabs the user, logs some information, and then returns its name. So basically, I'm simulating a real-world scenario where a backend service sends users data like name, email, age to a payment service for processing. This way, I'm testing how both REST and gRPC handle real data and heavy load. To hit these services with a flood of requests, I'm using autocannon for REST and GHZ for gRPC. These are powerful benchmarking tools. To make testing easier, I've also created two JavaScript files. One is right here. Let me close this. And the other one is right there. This file is just for testing the gRPC test, runs the GHZ test against the gRPC service using a child process. It has 100 connections and it runs for 20 seconds. It hits just the URL I showed for gRPC server. This one, REST test.js, runs the autocannon test against the REST service. It calls the process endpoint. Process endpoint is right there. And again, same condition, it has 100 connections and it lasts for 20 seconds. So let's run the servers to see what happens now. Let me close this. Okay, my gRPC server is running now on port 550. And I'm gonna try to run the gRPC file that I have here. As we can see, it's sending thousands of requests to the gRPC server, and this is gonna last for 20 seconds. Alrighty, the 20 seconds is over. Now I'm gonna do the same thing for the REST server that we have. The server is running on port 8080. I'm gonna run this one, which is REST test. Again, it's sending thousands of requests. These tests are running for 20 seconds. All right. Now I have the result of both tests. This one was for the REST API, and this one was for the gRPC test server that we have. My main focus is here. The average time that it took the gRPC server to process each request per second was 8.33 milliseconds. Let's see for the rest, the average was 9.05 milliseconds. Pretty much the same, not really. I don't see lots of benefit from gRPC right here. One thing to notice though, the gRPC server for 43 responses was unavailable. That's important to know. Of course, I'm not using just one payload. I've created 3 different payloads, small, large, and huge, to see how these APIs behave under different data sizes. So I have small, which has a bunch of data, name, age, email, phone, address for user, and large has more information, as you can see here, and huge has even more. So the tests I just ran were using the small JSON. Now I'm going to use the large one for both to see how increasing the volume of a JSON file would affect the result of each test. Okay. Running the gRPC server again. Again, same thing. Thousands of requests are being sent to the gRPC server. Now I'm running the test for, now I'm running the REST API we have. Awesome. It's running on port 8080. These tests are going to take, again, 20 seconds. Alrighty, the 20-second is over for both of them. Let's compare the result of each one. Okay, the average for the gRPC server with the large payload is 8.7, almost 8.07 milliseconds. Let's see, for the REST API is 9.53 milliseconds. So we can see that this time, because we have a larger payload, the REST API is taking just a bit longer. It's not really a lot, but almost 50.5 milliseconds. Now I'm going to repeat the exact same thing that I did for so far with the biggest payload we have. It's too huge. Okay, running the gRPC server again. Okay. Now let's run the REST API. Sending thousands of requests. So again, the point of this is to simulate how backend services really talk to each other under pressure, at scale, and with lots of data. Alrighty. Okay. Okay. Now let's compare what we have here with the biggest payload files that we had for these tests. This time, the average for the gRPC server is 9 milliseconds to process each request. And for the REST API is 11.79 milliseconds. So as we can see, the gap between the performance of a gRPC server versus a REST server or API is increasing based on the size of the input or the payload we have. So it's not a lot, as we can see, it's not like 11 versus 9, it's not a lot. But imagine if we have a giant base code where we have hundreds of endpoints, and each endpoint takes a bit less time in a gRPC server versus a REST server, what a big difference it would make in the future in the result of overall result of the API we have. Also, one thing to mention here is like this is just a really simple payload. In real life, there are cases where maybe a payload is smaller, maybe a payload is way larger than what I have right now. You get the point. So after running all these tests with small, large, and even huge payloads, here's what we found. When the data is small, REST and gRPC perform pretty similarly, right? In fact, REST sometimes handles a few more requests per second just because of how optimized tools like autocannon are versus GHC. I do believe autocannon is way more optimized also versus GHZ that I use to test the gRPC server. But as soon as we increase the payload size, gRPC starts to shine. It has lower average latency, better efficiency, and it handles structured, heavy data way more gracefully. REST still holds its own in terms of simplicity and slightly better tail latency in a few tests, but that's likely due to how connections were handled at the end, not because REST is faster overall. So when should we use each? We should use REST when we need human readable APIs or when we are building something that's going to be used in the browser or integrated with other services or systems. But if we are building backend microservices or real-time systems where performance actually matters, gRPC is the way to go. It's super efficient, faster with bigger data as we saw, and gives you strong typing with generated clients. Basically, REST is great for simplicity and reach. gRPC is better for speed and scalability. The way I would like to think about it too is like gRPC is like the Formula One car, blazing fast, but not everyone can drive it. REST is like a solid sedan, slower, but it works everywhere, everyone understands it, and it's super reliable, as we saw. Because if you remember, I can actually show it one more time. The gRPC could not respond or was not available for 80 of the requests, versus here, there is no failure. And one more thing, if our backend services are written in different languages, gRPC is actually a great choice. We can define everything once in a protofile and then generate the code for Go, Python, Java, Node.js, or whatever we are using. That means our services can all talk to each other without worrying about how to format the data or deal with inconsistent APIs. It's like having one shared language across our entire backend.